Hi guys, in this video we are going to discuss the first three questions from div 1 of starters 89. So the problems we are going to discuss are positive or negative subarrays, subarray removal and two averages. So let's get started. The very first problem is positive or negative subarrays. The problem states that considering a array A of length n, so there would be an array AI, the ith element of which would be 2 to the power I minus 1. So basically this entire array would be an array of powers of 2, right? And then we'll also be provided with the array B, which would either contain plus 1 or minus 1. Now what we have to do is we can multiply the ith element of A with the ith element of B, and we'll obtain the array C. So array C is the ith element of the array C is equal to Bi into Ai, right? Now it's pretty obvious that since we are having only plus 1 and minus 1s over here, so the final array that we are gonna get is also going to be a array of powers of 2, some of whose element or all of whose elements could be minus 1, right? So that is something we can predict right over here, or we can understand that. Now we have to tell them that if the count of the subarrays which have a sum strictly greater than 0 is P, and if the count of the subarrays which have a sum strictly less than 0 is Q, then we have to print the value of absolute of P and Q, as difference of P and Q, right? So how would we do it? Now very basic observation would help over here. So the very basic observation is that if we are having any power of 2, so let's say if we are having 2 to power I, let's change the color. So yeah, if we are having a 2 to power I, right, then even if I sum all the elements that are from 2 to power I minus 1 till 0 or till 1, this actually gives me a value 2 to power I minus 1. Let's try to understand it in detail. So let's say I have 1, 2, 4, 8, 16, 32, 64, so on and so forth, right? So this basically is the power of 2. This is 2 to the power 0, this is 2 to the power 1, this is 2, 3, 4, 5, and so on. So let's say I pick a random number. Let's say I pick 8 over here, right? So these three, when they would be summed, they would actually be 8 minus 1. When these numbers in entirety would be summed, these would be 16 minus 1, because 16 is the next number, right? So what we understand from this is that the number which is having a value 2 to the power I, right, it individually would be greater than all the numbers to its left, correct? And that is something we can use. So how can we use this over here in this particular question? So what we can say is that if you are having a plus 1 at any location, so if your B of I is plus 1, right, and your AI would definitely be 2 to the power I, right? So what would happen is, if it's plus 1, then any array which is ending at Bi, for example, let's say this was your AI and this was a Bi. Just let's take a small example. Let's say this was 1, 2, 4, right? And let's say this was plus 1, minus 1 maybe, right? Now if we take this, so the array C would be, let's just write down the array C as well. So this will be 1, 2 and minus 4, right? Let's add another element. Maybe this is 8 and maybe a plus 1 over here. This becomes 8 as well. So if I take this particular minus 4 and if I end my array at this particular index, then the subarray would always be having a negative sum, because the subarrays that would end at minus 4 would be 2 comma minus 4 and 1 2 comma minus 4. Oh, sorry, 1 2 minus 4. Also simply minus 4 would be an array. Similarly, if I take 8 as the last integer, so I'll be getting 1 2 minus 4 8. I'll also be getting minus 2 minus 4 8, right? And I'll also be getting minus 4 and 8. I'll also be getting a simply 8, right? So how many subarrays would end at a particular index I? So basically I plus 1 subarrays would end at any particular index, right? So this is something that we can use over here. So what we can say is that if your value of B of I, if it's positive, then all the arrays ending at this particular location are gonna be positive. If the value is negative, then all the arrays ending at this particular location are going to be negative. If you just want to see that, so this particular array has a sum of minus 2, right? This has a minus 4, minus 3, that is actually 3. Oh, sorry, that is actually minus 1. This would have minus 4 as a sum. So you can see all these arrays are having a negative sum. All the other arrays that are ending at like 8 or 2 or 1 would have a positive sum. So let's see the code for this. The code is fairly simple. So what we need to do is, I'm taking two variables P and negs, or you can take positive and negative, hardly matters. After that, if the value is negative, then you'll say the negative count subarrays would increase by I plus 1. if else the value would be positive, and the positive count of arrays would increase by I plus 1, and at the end you print p minus negative or positive minus negative. So yeah, that's it for this particular question. Let's move to the next one. And subarray removal is the next problem we're going to discuss. The problem states that you have a permutation A of length n, right? And then you can remove a subarray out of it, but you cannot remove the entire array. So definitely the entire array is also a subarray, but it's not a proper subarray. So you have to remove a subarray that is having a size less than n, right? That is something they have given. Now the way we have to remove this subarray should be such that if the remaining elements are then combined, then they should form a valid permutation. So to give an example, what I can say is, let's say I had this particular array 1, 2, 5, 4, 3, right? Now in this particular subarray, I can remove 5 and the remaining array would be 1, 2, 4, 3, right? I could also remove, okay, let's write that again. Yep. Okay, I could also remove 5 and 4. The remaining subarray would be 1, 2, 3. That's also valid permutation. I could remove 5, 4, 3. The remaining permutation would have been 1, 2. I can remove 1, 2, 5, 4, 3. The remaining permutation would be 1. Now, would it always be the case that I can remove all the elements except 1? Not really. Let's say my array was something like 4, 1, 2, 5, 3. Now I cannot remove anything except for 5, right? I can just remove one element, and the remaining would be 1, 2, 4, 1, 2, 5, 3. Oh, sorry, 4, 1, 2, 3, right? But I cannot expand the boundary of this particular element, because if I do that, then the remaining elements would not form a valid permutation. So yeah, that's it about the question. So how do we solve it? Now, easier way to solve it would be that we can try for all of the valid permutations. So I can say that, okay, I'm going to try for 1, 2, 4, 1, 2, 3, 4, 5, right? So I'm going to exclude a 5. Excluding a 5 is always easy. That's fine. Then I'm going to find that is it possible to construct a permutation 1, 2, 3. Then I'm going to find, is it possible to construct a permutation 1, 2. However, we'll have to do this particular operation n times, right? And in order to check whether it's possible to construct such a permutation, will also require order of n time. So collectively, it would require order of n square time, and that's why it would fail. So we kind of require a trick over here that would help us to boil down the decrease the complexity of this algorithm. So yeah, a good technique can be used. I don't know if it's a formal technique, but what you can actually do is that you can say that, okay, I can always remove the nth element, right? Now you have to check, can you remove the n minus 1th element? If you can remove that, then remove it. But if you can't, then go to n minus 2, or simply keep checking for n minus 3, n minus 4, n minus 5, and so on. But how would you even do it? Now it's easier to say, but how would you do it? Now let's write the permutation again. So let's write a different permutation. Let's call it 2, 1, 4, 5, 3. This is a valid permutation of 5 digits, right? Okay. So if I want to remove the 5th element, I can remove that. 5th can be removed, right? Now I'll say, can I remove the 4th element? So where's 4? Here's my 4th, right? So I'll say, okay, I want to remove the 4th element. What are the values that I need to calculate now? So I'll keep two values, L and R. L would basically define the left boundary of the subarray I'm going to remove, and R would define the right boundary of the subarray I'm going to remove. So initially, if I give it indices 0, 1, 2, 3, 4, right? So initially my L is equal to 3 and my R is also equal to 3, right? Now as soon as I say that I'm going to include this 4, so what would happen is I'll say L is equal to minimum of initial L whatever I'm having and the current index, right? Let's call it I. So now L would become 2 and R is equal to max of R comma I. So R would remain 3. Now what I'll observe is that my left boundary is set as 2, my right boundary is set at 3. So the number of elements within the boundaries are R minus L plus 1. That are 2 elements. And how many elements do I expect to be in the boundary? So I'm currently at n minus I or n minus 1. So basically I'm expecting that there are 2 elements, n comma n minus 1, that should be in this particular boundary. So 2 elements should be there. And from this, we know that, okay, 2 elements are already there. So the count matches. That basically means the subarray I'm considering, it has exactly 2 elements, and those 2 elements are the ones we were expecting them to be. So they are n minus 1, and they can be in any order, right? and these fit. So we already have a valid answer, and we'll keep checking it. So then we'll check for n minus 2, then we'll check for n minus 3, so on and so forth. I hope the algorithm is clear. Let's look at the solution for the same. So if I go to the solution, yep. So initially, in order to know the locations of each of these elements, I'm using a map. After that, I'm setting my left and right. So initially they would be set to the value where the nth element is located. After that, I'm setting my res or the result to 1, right? Because you can always remove one element, you can always remove the nth element, and the permutation would then become a permutation of n minus 1 elements. Then I'll say my L is minimum of L comma MP minus 1 or MPI, and my R is equal to maximum of R comma location of the ith element, right? After that, I'll check that this is the size of the subarray, right? R minus L plus 1 gives the size of the subarrays under the boundaries L and R. If this size is equal to number of elements I'm expecting, so why is it n minus I plus 1? Because we are traversing from n to 0 or n to 2, right? So we are technically saying that we are going to go for 5 first, then 4, 3, 2, 1, right? So basically n minus I would actually give you the number of elements minus 1, right? So for example, if you're saying that you need the element 4, right? Or you're talking with the element 4. So basically the number of elements you're expecting is 5 minus 4 plus 1. That would give you 2, right? Because you're expecting 5 and 4 should be the 2 elements that should be present in this particular array. So if this condition matches, that means the number of elements in your subarray is equal to the number of elements that were supposed to be there. Only in that case, you can say that, okay, the valid subarray has been formed and you can update your result. At the end, you'll output your result. If you run it, okay, there's some problem with the header file, never mind. Yeah, if you run this will work perfectly fine. I've already submitted it. So let's move to the next problem. So the next problem is 2 averages. Since the problem statement is a bit long, I'll try to explain the problem on the iPad itself. So the problem states that you are given an array A. Okay, so there's an array A of length m, and there's a of length n, sorry, and an array B of length m, right? And they all of those elements are less than or equal to k and greater than or equal to 1. So AI is less than or equal to k is greater than or equal to 1. Similarly, BI is less than or equal to k is greater than or equal to 1. So this is the thing that they have already mentioned. Yeah, looks fine now. What we have to do is that in one operation, we can add any element from 1 to k in either A or in B, right? And we'll keep operating till the time the mean of A, mean over here basically means the average. Mean actually means the average, but they had clarified in the question, so I also clarified over here. So the mean of A, or let's call it A mean, should be strictly greater than B mean, right? Till the time you'll keep operating it, and maybe like it's possible that even initially the mean of A was greater than mean of B, then you'll print that okay, 0 operations are required. Else you'll print how many operations are required. However, if this approach or any number of operations cannot get you to this particular inequality, in that case you'll have to print -1. So let's firstly try to tackle that even is -1 even possible. Technically -1 is possible only in one case. Now let's say your k is set to 1, right? And since all the elements have to be greater than or equal to k and less than or equal to k and greater than or equal to 1, so all the elements are technically 1 itself, right? So you can have infinite number of ones and its mean is always going to be 1, right? So no matter how many elements you have, the mean of A and the mean of B is always greater than 1, is always equal to 1. So you'll never have the case wherein the mean of A is greater than or equal to mean of B. So if your k is set to 1, then your answer cannot come. Like you can never satisfy this inequality. However, if k is not equal to 1, then you can proceed with the answer. In some finite number of steps, you will be able to come up with the answer itself, right? So now comes the question that is there a defined way of doing it? Like one could argue that maybe it's always better to keep adding. So since we want that the mean of A should be greater than mean of B, so one could argue that let's always keep adding k, because k is the maximum element you can add, right? So let's keep adding k to A, right? Or one could say that in order to decrease the mean of B, we can keep adding 1 to B, right? Because you have to understand that mean actually is the sum divided by the number of elements, right? Let's call them n. So either if you are increasing the sum, right, then your value is going to increase. However, if your denominator is increasing, then your value can decrease depending on what your initial values are. If you are just adding 1 to b, right, then what would happen is that the minimum mean is anyway 1, right? Minimum mean is 1. It cannot be lower than that. So if you are adding 1 to b and you keep on adding 1 to b, then basically the mean of b would start converging to 1, right? And the maximum mean can be k itself, right? Because each elements can go up to k. So if you keep adding k's into a, then your mean would start converging to k itself. But it's not always optimal that either a would either this particular operation. Let's just change the color of this. Okay, so it's not always optimal that this particular operation, let's call this operation 1, or this particular operation, let's call this operation 2, that either 1 or 2 would be the correct choice. So it could be possible that initially you need some amount of operation 1s and then maybe some amounts of operation 2, right? But it's never the case that you'll know for sure that it's never the case that you can be sure that the only operation A or only operation B can get you the right answer in the minimum number of steps. But how would we compare that, whether we should follow operation 1 or operation 2? What we can do over here is we can check that which of the operation minimizes the difference between the means. So let's call A mean as AM and B mean as BM, right? So now I know that if I add, and let's call the sum of A as AS and the number of elements as N, let's call the sum of B as BS and the number of elements as M. Now if I add a K to A, then what would happen is that the mean would become A of S plus K divided by N plus 1, right? If I add a 1 to B, then the mean would become B of S plus 1 divided by M plus 1, right? So now this is the initial value, this is the final value. Similarly, this is the initial value. Okay, this is the initial value, this is the final value, right? So if I do the operation 1, then basically I'm saying that A of S plus K divided by N plus 1, if I subtract the initial mean of B, that was B of M, right? So this would give me some value. I definitely want this value to be positive, right? If it's greater than 0, then the inequality is already satisfied, because we basically wanted that mean of A is greater than mean of B, right? We want this to be positive. So I can say that if this value is greater than, okay, A of S or A of M, or the mean of A, the initial mean of A without performing on it, minus the mean of B if we perform on it. So the mean of B if we perform on it is given by this. So yeah, okay, that was not good. Anyway, okay, anyway, it's B of S divided by M plus 1, right? B of S plus 1 divided by M plus 1. If this scenario holds, right? If this scenario holds, then we get an idea that it's always better to increment K, right? Or in this particular step, we can increment A by amount K, right? However, if this does not hold, then that basically means that if we are going to increment our array B by a value 1, then the difference between these two values is going to get minimized, right? Or we are going to move towards the positive value. So that's exactly what we wanted. So by a simple if statement, we'll simply check that if this is happening, then increment A by K, else increment B by 1. Now, interestingly enough, it could have been the case that because of floating point precision, this could have given you a wrong answer, right? And in that case, you could have you would have required to use some tricks or some other logic, but it doesn't happen in this case. So this code is perfectly working fine. So as explained, firstly we'll check that if K is equal to 1, in that case the answer is -1. Then we'll start a while loop. Now the reason I'm just starting a while with a 1 over here is because as soon as the condition is satisfied, I'll break. And as explained earlier, if your K is not equal to 1, then your answer definitely exists, right? So I'm not afraid of the fact that this is going to be an infinite loop, because it's always going to terminate over here. Then I check that if it's better to add a k to my a value, right? If this particular value is greater than adding the a 1 to a b, in that case I increment my a by k, I increment the number of elements in a. Else I increment the number of firstly b by 1, or I add a value 1 in the array b. I increment the number of elements, right? And as many time as this loop runs, I keep incrementing the variable ops that is initially set to 0, that basically defines the number of operations, right? At the end I print that out. So if I run it, this works perfectly fine. Yep. So that's it for this video. Let me know if you still have a doubt. I'm more than happy to help you out. Cool guys, thanks a lot. Bye bye.